Hello. So welcome to this practice session on functions. So in this practice session, I will be discussing what are called as functions. I will be going through the basic definitions, how to create a function, what are positional arguments, what are keyword arguments, and things like that. Okay. So okay. So previously in my previous videos, I had defined how to deal with control flows. So for example, things like for I in 1000 and then 20 and then 300, you know print I, right? So what it will do is it will just iterate through this iterable. So this is a list, and it's also an iterable, and will iterate through each and every element in the list, and then it will print out, right? Uh, right. And also we discussed something called as a range object for um, I in oops. So for I in range 10 to 100 with a step of 10, you just print I. So here what happens is that it will just print out 10, 20, 30, 40, 50, etc., right? So with a step of 10. Okay. And also we saw while loop. So j is 0, and while j is less than, let's say, 10, print I. And don't forget to increase the j inside the while loop. For example, if you don't specify that, this will just run into an infinite loop, right? So it will just keep going forever, and then that's really not good for my machine here. So I should just press interrupt, and it should just stop here. Yeah, so this is not good, right? It will go into an infinite loop. So always when you have while j less than 10, you just make sure that inside j is plus equal to 1, right? And that will just do fine, right? So when j becomes 10 or more than 10, it will just stop. Okay, so that's something we need to take care. And also I discussed something called as break statement, and continue. So for example, x equal to 0, while true, right? So that means that this loop is going to run forever because it's true always, unless some condition comes inside the loop which makes it false, right? Which, like break statement, right? So print x, and then let's increase the x by 1, and then if x is bigger than 100, break, right? And we can add one more loop inside while true, print x, and then we can increase x by 1 once again. And then if x is bigger than 50, then print like exiting from the loop, right? And then just break, break, right? So let me tell you what will happen here. So while true, print x, and then you increase the x by 1, and then if x is bigger than 100, it will just break, right? uh, but it will enter. So when it goes through this, right, and it will evaluate this. If x is bigger than 100, it's not bigger than 100, so it will enter this loop, right? It will enter this loop, and then it will print x, and then increase by 1, and then it will do this, right? Right. So if x is bigger than 50, it will start printing this. So it will and it will just break out, and it will break out of this loop, right? This loop, and it will go to the bigger one, right? And it will keep running unless x is bigger than 100. So let me just show you what happens here. So you see 0, 1, 2, 3, 4, 5. So basically this is being printed when it so it's inside the loop. It goes inside this one, and then it's printing it out. And when it becomes 50, right, when it's bigger than 50, it just prints exiting from the loop, right? And then it breaks, it goes back, and then again comes inside. then it prints 51, and then it comes inside, and then it prints 52, and then it prints exiting from the loop, etc. Right. So this is not a good example, I guess, to understand the break statement. And but the point here is that break will exit from the immediate loop, right? The immediate loop, and not the whole thing, right? Not the whole loop. Okay. So that's what we discussed previously, and now let's jump into functions, right? Functions. So what are functions? So functions in math, functions are something which has which, if you just give an input, and there's this thing which happens inside, and then it gives an output, right? This is what happens. So exactly this is going to happen in the Python functions. It's built by the same logic in mind, or the same math function in mind. And also we had discussed import math, right? The math module. So import math, and then math dot, if you just look at the functions inside, so all of them are functions, right? Like ERF, factorial, floor, fmod, a lot of them, right? These are all functions. So basically, if you just plug in, if you just give an input, it will give you an output, right? And to understand what is this output, you need to know things about the function, right? So this is like a custom function. This is a function which is already inbuilt in Python in math module. But how do you create a function from scratch, right? So what are functions to just begin with, right? Functions are basically functions are in Python, they are blocks of codes which can be run multiple times, right? Or multiple times, or can be executed multiple times, right? So these are functions, right? Okay, so now let's try to define a function, right? Let me define a function called the Fibonacci function, right? So in math, we know what is a Fibonacci, right? Or Fibonacci sequence, or Fibonacci numbers. They are, so you start with 0, 1, and then you start adding the previous two numbers. So 1 plus 0 is 1, and then 1 plus 1 is 2, and then 2 plus 1 is 3, and then 3 plus 2 is 5, and 8, 13, etc., right? So you just add the previous two numbers, and what you get is the Fibonacci series. So if you want to make this into a function which can give you any Fibonacci number given an n, right? Fibonacci number less than n. So to create such a function, so in math, in math, we all know that there is something called as definition, right? So in the same way, we will define a function. So you give this code here, so called def, and then you give the name of the function that you want to create. So let's call it Fibo NACCI, right? And then you give an open and closed bracket, right? And inside this, you will pass on what are called the arguments, right? So those are the or the parameters. So what all arguments that you can pass into this function is what you will define there, right? So maybe you just this function just takes in one it has one parameter, or takes in one argument. So let's give it just a number n, and then Fibonacci n. Then what you will do is we'll just define a and b. This is equal to 0, 1, right? So this is simultaneous assignment. So a is assigned to 0, b is assigned to 1, or it's another way of assigning, right, instead of a equal to 0 and then next line b equal to 1. You can do this in this way, and then what you do is while a is less than n, you just print out a and then end with with the space, and then what you do is each time your a and b is going to change. So a will become b and then b will become a plus b, right? So this is what is happening. So a becomes b, but b becomes the sum of last two. So if you start with 0 1, a is 0, b is 1, then a becomes 1 in the next iteration, and then b becomes sum of these two, which is 1, right? So now a is 1, b is 1. The same way it keeps going, right? So now this is what happens, and then what you need to do is you just need to return something, right? So this return is something which the function is going to give an output, right? It's going to give you an output. So that's where you do this statement return, and then whatever you want to return, you can print it there. You can just type it there, whatever variable that the function returns, right? But maybe the function need not return as well anything, right? In this case, we can even define this function without a return statement, and it will just work fine. So fibo NACCI of 4, let's calculate this. So you see it is printing out 0 1 2 3, right? 3 is less than 4, and so that's why it has 5 elements here, and you can check for even larger numbers like 13, and you see this is what we get. So so this is our function, right? So we define a function, and if you just input, this is called the argument that you pass into, and these are called the parameters of the function. So n is a parameter of the function. So basically an argument is something that you pass into the function, right? And when you define the function, you are giving this variable n, that's the parameter, right? So it's not defined here, but it can accept n can be any number or anything, or depending on what you are inputting here, right? Right. So of course n cannot be any other data type except floats and ints, right? In this case, of course, a float will work, like 9.5, and it will just work fine, but it cannot accept data types like lists, tuples, dictionary, etc., because inside the code we have written the code in such a way that we are assuming n to be floats or int, right? So that's what is this function all about. But let's define another function to make it more clear. So let x be 100, and let's define def and then square num, right? That's the name of the function, and then open and close bracket. And again, you need not pass any parameters to this function. This is just a function without any parameters, right? And then this time I want to show you the return statement, right, which I did not include here because in this case, so let me just make things more clear. If you just look at the type, right, of, okay, maybe before going in there, like I should really, maybe I can just explain type of fibo NACCI. What is this? This is a function, right? So the type is function, right? Note, if I include open and close for, let's say that, it will say none type, right? And this is it's just printing the thing, but the type is none type, right? What does that mean? It means it is a none type. It is not returning anything. That's why it's a none type. So let me explain here. So when I put a return statement to this one, let's say return of, as this is a square number, right? So it should be x star star 2. So this function, whenever you call this function, it will return the square of x, right? So sqr num and then open and close bracket, and then it will give you 1000, right? So now this is the power of return statement. It will return something. So what you can do here is that if you can define a variable y equal to square num, And then if you check y, it's 10,000. Okay, right? So y is 10,000, but the same thing you cannot do with Fibonacci, right? Fibonacci of 4, let's say. Okay, it's printing out something, but if you just check y, it's nothing, right? It's none type, because the reason is because this particular function has not returned anything. It's just printing out things, but it is not returning anything. But here it is returning the square, right? So that's why you can assign it to a variable y, and y will be 10,000, right? So that is something interesting. And next thing is that, of course, in Python there is a inbuilt power function, right? So basically it takes in it has two parameters, or it takes in two arguments, and then if you just pass power of x and 2, that means x raised to 2. So now if you check y, it is 10,000. Or let me make it different, z, right? Z, right, 10,000, right? That's a predefined function. Again, if you just check the type this time, type of z, or let me just pow of 3,2. So what's that? It's an integer, right? Integer, because it's returning an integer. So I guess I cannot try this, right? But I can try without any open and square brackets. So this time it's saying the type is built-in function or a method, right? So it's a built-in function, right? If you had tested the square num, it will say function that we had defined, square num. See, this is a function that we had defined, right? And of course, the thing that the function returns need not be just a number. It can return anything, right? It can return any data type. So let's just copy this, and let's just paste it here, and let's this time return x comma x star star 2, right? So in this case, when you do this is a tuple, right? So you can check the type of sqr and num. That's of course it's a function, but if you just look at the output, it's a tuple, right? It's a tuple. So now you can you can just pass it into z. Then when you look at z, it's a tuple, right? 10,000 and 10,000, right? Yeah, so that's something which you can do with the defined functions. It can output any particular data type. Now, another thing that I want to mention is the arguments, right? The arguments for the functions, right? This square num function does not have any argument, right? It doesn't need any argument, but we can define a function. Let's define a function which takes in two arguments. So copy and then paste it, and okay, so this time let's say y comma x. So these are the two parameters, so that means it will accept two arguments, and then let's do the return z is equal to y star star x, right? And then return z, right? Now sqr and num, and now you need to pass. Okay, so let me make it different. Square num 1, right? So square num 1, and then it will take two arguments, right? So so for y I will pass 1, and then for x I will pass 2, so it will give me the output 1, right, which is 1 star star 2, or 1 raised to 2, right? So this form of passing on arguments to this function, it's called as positional argument. So it's positional arguments. So what are positional arguments? So basically when you pass 1 and then 2, Python assumes that 1 or y is assigned to 1, and 2 is assigned or x is equal to 2, or 2 is assigned to x, right? Whichever way you want to say it. So basically, position wise, it is assigned to the corresponding variables y and x, right? But there's another way of specifying variables or passing on arguments. So this is basically keyword argument. So you will say y is equal to 1 comma x is equal to 2, right? This works just fine. And of course, when you're passing, so this is called as keyword arguments, and of course, when you pass arguments using keywords, you need not worry about the order or the position, right? You can say x equal to 2 first, and then say y equal to 1, right? This just works fine. So the order doesn't matter when you pass keyword arguments, right? But if you are trying to mix them together, right, that is, you are giving a positional argument and a keyword argument, then the order matters, right? So first you are going to pass a positional argument, and then if you want to pass a keyword argument, then it's fine, right? So then x is equal to 2. This will just work fine, right? Or let's change the thing, 3 and then 6, right? This works fine. But what happens if I try to pass x equal to 6 and then let's say 3? See, it will give me an error, right? Syntax error. Positional argument follows keyword argument. So this doesn't make sense to Python, and it's okay, it's clear, right? Because when all the positional arguments need to come first before the keyword argument, so that Python knows that the Python knows that 3 means y, and then if there were like many other arguments, let's say, right, you can pass on as many arguments as you want, so y, x, z, w, whatever you want to make it, and you can pass positional arguments, right? So let's say you want to pass positional arguments for these two and then keyword arguments for the rest, right? So that you can do. So just 3, and then let me say 3 again, and then you want to pass the keyword argument, so whichever order, right? So w is equal to 7, and then let's say z equal to 6, right? So I just need to run this, and of course if I run this, all this will be wrong because I need to pass on 2 other parameters, right? So the idea is clear here, right? So the thing is, if you want to pass positional arguments, it should come before keyword arguments, and also when you pass positional arguments, the position matters, right? Now y is 3, x is 3, and then keyword argument, it's fine, right? You're assigning w is equal to 7, z equal to 6. So Python knows that w is 7 and z is 6, right? Okay, so let me just keep it like this, and let's just remove z and w. Okay, so that is something which you need to be careful when you pass keyword argument and positional arguments when you are mixing it together, right? Okay, so the same logic holds when you create functions, right? When you are creating a function, and what happens is that sometimes, let's say this time, let's just create a function with a lot of variables, right? And let's say something happens inside. I'm not going to do anything with the other variables, but you can play around with them, like z is equal to, or this is gonna throw an error. So let's assume a to be y star star x, and then you can do things with z, w, and then e, and then c. Things can be done, but that's okay. So let's just create this function here, right? So now it is difficult for the user to give 1 2 3 6, right? 4 5 6 arguments. It is so tedious, so cumbersome to so inconvenient to pass 6 arguments. So what will you do? So you can, pre-assign some of these parameters that you can pre-assign to them, like equal to 4, w equal to 7, etc. This is like, a pre-assignment. So that means even if the user uh, has not given any input, let's say 1, 2, and 3, right? It will work fine, right? So because W and E and C, if the corresponding uh, arguments for W, E, and C are not passed, then Python knows that okay, it is here, right? W is 7, E is 4, and C is 3, right? This is called pre-assigned variables or default arguments, right? Default arguments, right? Uh, Sorry, the spelling is wrong. Default arguments, right? Default arguments comes in so much handy when you have functions, and of course when you go into a data science course and when you look at all those big functions, there are a lot of arguments that you can pass, and it's not possible to pass on each and every argument. So what happens is that those functions have default arguments, right? The default values are there for you, so you don't need to pass on everything. Maybe you just need to pass the important ones, right? And that will do the job, right? So that's one point. Another point that I want to make is when you create a function like this, y, x, z, and then I assign w equal to 7, e equal to 4, c equal to 3, right? But if I had given, let's say, z here, this will say non-default arguments follows default arguments. So again, this Python does not allow. You need to give default ones after the non-default ones, right? So that is something which you must take care when you define a function as well. And another thing I want to mention is that sometimes these are simple functions, right? Like 1, 2, 3 line code, right? All these functions. But sometimes in Python, you can find inbuilt functions which are so long, and you need some kind of a documentation to know what this function is all about, right? So that's why we have something called as doc strings. So basically doc strings are something which you just which you can a kind of strings which you put under these three codes, right? And inside which you can just say what your function is all about. So it squares, or not square, it takes the power of y to the x, right? And has some useless arguments, right? Or parameters. Okay, and what's the use of this? Basically, what you do is sqr_num, and then inside, you can, when you just place your cursor here and then do shift plus tab, then it will just pop up, a thing like this. It will show its type as function, file, and okay, this time it says docstring is empty. Let's figure it out why the docstring is empty here. It should not be empty. So this should be, so okay, of course, our function is not sqr_num, but it's the /1, right? Now, if you do shift and tab, then it will show you the docstring. It takes the power of y to the x and has some useless parameters, right? So that's docstrings, right? So it's something which you can write, within single quotes, 3 single quotes, and close it with 3 single quotes, and then you know, it stays. So you want to check what that docstring is about, you can just go and you know, you can check it out, right? Okay, so I just want to check whether this will take in, you know, double quotes. I guess it will do, maybe. Okay, let's just check whether this will work. Usually it's single quotes. Yeah, so no docs. Okay, so again, I'm making that same mistake. So it's 1 and then do shift tab. Okay, so it works even if it's so the basically it should have 3 quotes, right? Three quotes like this, and then it will show the docstring, right? So that makes sense, right? Now, in all of my functions, there are, you know, finite number of arguments that you can pass, right? But what happens if you want to create a function which can take an arbitrary number of arguments, right? Well, you can do that. And that is really needed as well, because, you know, for some functions, it is not convenient to limit the number of arguments that you can pass. So in that case, we have some, you know, functions which take arbitrary number of you know, arguments, or arbitrary. Let's start with positional arguments. So functions which take arbitrary positional arguments can be defined as follows. So def as always, and then the function name, let's say add num. So I'm going to add some number. So this function is going to take arbitrary number of inputs and then add them together, right? So the only difference that's going to happen is inside the, you know, brackets, right? Open and closed bracket. Inside that, you basically are going to put a star and then an X, right? So what happens is that now this function can take in as many arguments as you want to pass into, right? So let's just say some num as a variable, which I'm going to assign it to 0. And then for I in X, I'm going to, you know, do some num plus equal to I, and then return some num, right? Oh, so let's do the return here. That is, if you do the return there, then just after one iteration, it's just gonna stop, right? So after return, once the function has executed the return statement, then it just stops, right? So that's the thing with the function. And also another thing that I want to mention is that, see here, I said for I in X, right? So that means my X is an iterable, right? It's an iterable. So I'm passing it onto this for loop, right? So what does that mean? So what is X then, basically? What is X? So let's just return X this time, and or maybe just let's demonstrate what does this function do, right? So add num, and then as I said, I can pass on as many arguments as I want, 5.8, 4, 5, as many as I want, right? And then do shift enter, then it will just give me the output, which is basically the sum of all of them, right? So what is X? So basically X is a tuple, right? It's a tuple. So when you pass these many arguments, it becomes a tuple X. So let me just show you. Instead, if I just return X, let's just do this one, and then see the argument, the resultant X is basically a tuple, right? It's a tuple. So yeah, so it's a tuple, and you're just summing all the numbers inside a tuple, and that's what happens here, right? So this is basically a function which can take arbitrary number of positional arguments, right? Okay, so now let's talk about how to create a function which takes on arbitrary number of, you know, keyword arguments, right? Keyword arguments. So again, the procedure is the same, def, and then let's create, maybe let's do the same thing. So add num, and then the thing happens inside the open and square bracket. So instead of 1 star, you're gonna put 2 stars and just some variable, let's say y. Okay, so this time you can pass a keyword argument. So let's keep the function the same, right? So this is same as here. Just copy it, then just paste it, and then return sum num, right? Okay, so of course, so there is I just have to do this and it will work fine, and then add num. And now see, if I try to now pass some positional arguments, it's gonna give me an error saying that it accepts 0 positional arguments. So this time we have to pass keyword arguments, right? And also there's an error in this function is not going to work out, because you need to put something called as x dot values, right? Now it's going to work out, because the thing is here what happens is that when you pass keyword arguments, so how are you going to pass keyword arguments? So maybe val1, right? That's is 1 key, and I'm going to say it's 1, and val2 I'm going to say that's equal to 5, and val3, and that is 89 or whatever, right? So you can keep giving any kind of key and its value, right? So key value, that reminds us of something, right? Dictionaries, right? So y is basically a dictionary. So it will store all these key value pairs, and when this code works, it's basically accessing a dictionary. So I have to specify x dot values, right? And we have seen before that x dot values is basically it shows all the values in a dictionary, right? So so let's look at this attribute error. Okay, so int object has no attribute values. Of course, it should be a y, right? And it's gonna work fine, right? So it's basically the same thing as before. It just sums all the values, but you're passing key value pairs, right? So this function can accept arbitrary keyword arguments, right? If you want to check the output, the y, you can do that. See, it's a dictionary, right? It's a dictionary, right? Of course, you can create any kind of function. So let's say a function which will greet the user, and then for name in names, and then let's say we have to give a message to them saying hello plus name dot title. So we have seen what is a title. Title is basically, it will make it into a title case. So basically the first letter becomes caps. So in a sentence, if there are words beginning after a space, so all those words will start with the first letter being caps, right? So that's basically your title, right? So make it into a title, and then print basically MSG, right? So this time let's just so look at this. So name in name. So this time the function is assuming that the user will pass in an iterable, right? So there are many things you can do. So let's make it into a star. So that means when you do greet user, it can take names. So let's say Jack and Ryan, Geoff, and like that. You can pass on any names, any number of names, and then it will output, right? So this time it's gonna take as many input as you want to pass into it. And so let's make it much more beautiful, right? So we'll say hello Jack, hello Ryan, etc. Or if you want to pass a keyword argument, keyword arbitrary number of keyword arguments, then you need to say name1, right? Name1 is I'm passing Jack, and then I'll say name2 is Ryan, name3 is Geoff, name4 is Tom, right? And it will so for names this time there's some trouble, right? You need the values, but it's accessing the keys, right? So what we need to do is names dot values, right? Now it will just work fine, right? So that's when you have a dictionary, you need to be careful. Okay, so that is a function which accepts arbitrary number of keyword arguments. Well, you can create a lot of functions with these two things, right? It's which accepts arbitrary number of positional arguments and arbitrary number of keyword arguments, right? Right. Okay, so here's something else I wanted to mention. Because we are getting used to the dictionary data type. So let's just create this kind of a function with some random name and then num as a parameter, and then my dictionary is just an empty dictionary. And let's say you want to create a function, right, which accepts the name of the student and the marks, and then it's going to store it in this dictionary here, and it will give you the output dictionary at the end, right? So for I in range num, so the number of students in a class, then how are you going to pass the key value pairs into the dictionary? So basically what you do is my dictionary, and then equal to, so basically you need to pass the key and the value, right? So what I will do is here, there are many ways of doing this. So either you can create a variable here and then say this is input, enter the roll number, right? Or the name of the student, that also works, right? Name, and here the output is so basically you want to pass J here, so J is the key, and then the value is going to be another input, which is basically enter the marks, right? And do this for all the students in the class, and then at the end return my dictionary, NARY, right? Right, RN. Okay. For I in range, sorry, it's okay, so this is good. Yeah, so let's call this function, right? impdemo1, and let's say there are 3 students, and now it will ask you for first the name. So let's just say Jack Power, his marks 23, Tom, his name is 45, Zach will be 67, right? At the end it will give you the dictionary, right? Or maybe if you didn't want to pass the key outside here, you can actually put the thing here. So input, enter the marks, enter the name, sorry, inside here, right? And then let's just try to run this and see what happens. So first enter the marks, right? So this time this function is asking me for the marks and then the name, right? So that's a bit odd. So I just wanted to just show you this difference, right? So but the output is the same, right? It's the name and then the values, right? Of course, if you want the values to be, floating point, you just say float, and then it will just work fine, right? All the outputs will be in floats, right? So yeah, so this is a function which you can use to take in the name and output the values, right? Great. So I guess that's it for the functions. So what all did we see? So functions, we defined, a way to define a function is using the def function, the name of the function, and then whatever thing that you want to do inside in the body of the function, and then basically you return the function, return the output, whatever you want to return, right? It's not necessary that you want to return something. You can just leave it blank. In that case, your output is like none. So it's a none type function. And then we saw, positional arguments, keyword arguments, and then I defined, function which takes arbitrary positional argument and then arbitrary keyword argument. So basically, here the X is a tuple, this is a dictionary, and then I define, I just showed you some examples. So I guess this is good enough for a practice session for Python functions. So I'll next video I'll discuss further basics in Python. Okay, so I'll see you next time. Bye.